and then I won't squint in the sun. I just won't be squinty if I just do this, right? This is what people do to their face anyways, right? Little invisible strings. We live in LA, so I should just have a face like this. I like this one a lot. This is Dolly. The last time we shot Dolly was the intro for Dolly, and we started to paint the picture of what we're gonna be doing. Something good about a 4-door F100. Right now we have a mock-up phase. I think what we need to talk about is the main element that's missing out of here, which is the frame rail, so let's go outside. Let's talk about this right now. That's at least 20 to 22 feet right there. With Dolly, just to recap a little bit for you guys, farm truck essence, capable, big parts in all the right spots, but we're not talking Barstow, Maine, big, huge holes. We're talking fun as shit, easy for the wife to drive, holds 6 people, coilover off of the axle, beam truck, converting the straight axle so we're not doing live axle stuff in the front. You know, simplified. Usable bed, tailgate, 40s, all the stuff. This is the frame that we were gonna use. If you can, Joe, let's just start running through this, right? We're gonna bail on the bumper. We're gonna cut it off. There's an overlay plate here. That's gonna get cut off. There's a shackle. That's gonna get cut off. There's a cradle. That's gonna get cut off. Cut off, cut off, cut off, cut off, cut out, cut out, cut out. Almost might leave that just for the artistic value of those welds. Cut out, cut off, cut off. Then you're left with this frame. So just think about the multitude of items I already covered. Then you're gonna cut those with a cutoff wheel. If you're doing a good job, you're gonna be able to get them off without marring into the frame. More than likely, you're gonna mar into some of the frame. So then you're gonna fill the mars or the excess cuts from the cutoff wheel or whatever you cut this thing off with, and you're gonna fill those and then you're gonna sand this. On top of that, you're gonna wanna streamline the frame. Every hole, okay, so over 100 holes, every hole needs to be filled to really have a clean essence of frame rail under your car. And then you're gonna box the frame. So then on the entire inside, there is no boxing. You know, a lot of trucks are like partial, where up to the trans mount, from the front of the car to the trans mount, it's boxed. There is no boxing. So then you're gonna box the frame. And then you're gonna weld all of that area where the frame is boxed, which is, so call it 20 feet. So, 80 feet of welding on a double pass program. This doesn't make sense. And you go, okay, well, then you're doing a tube chassis. Yeah, we're gonna definitely do a tube chassis, but it's gonna be a rectangular tube chassis out of A500 2x6. And that's what I wanted to go through with you guys. Sometimes you have to make a call here where like this doesn't make sense, especially financially for the client. Doing all this, unless there's something you find of value here that you're either gonna keep or that you need this frame here, it's only gonna hurt you. And I always press on tube chassis cars because for what you're doing with a tube chassis car, even where this frame lands, you're building another secondary structure out here for the cage just to get back into here from the outer extremities of the pillars. It's tough. So what this does is this gives us an opportunity to not only save a ton of time and money, keep something super clean, and then it lets us build a similar platform where it will be rails, but it lets us build it with the proper up travel, because on top of that, if we're doing this, we're also gonna have to kick this up to get the up travel we want and the ride height we want established into the car. So we're already cutting this frame, kicking it like an old SI or New Line truck, putting it back, plating it. I think we get the point here, right? So let's go look at the F100. So this leads us to frame. I didn't want to, well, let's say this leads us to a replacement frame. I didn't want to just use mild steel. First things with mild steel is the strength of mild steel sucks. I mean, no matter what, any frame that you have out there is going to be mild steel, but at least it's not like recycled mild steel. I think you might get a win, you know, like an old 70s truck, that it might not be crazy recycled mild, but it's still mild. So A500 is structural rectangular tubing. That's what we have is A500 2x6. And if you look under here, you can already see how streamlined we're going to start getting the frame. This has been what Luke's taken on as a project. He is in charge. So again, it always goes back to, I do all the design direction, and then my guys, they develop their skill sets to execute on the design. So what Luke is doing right now is he's got all this plotted in SolidWorks. He's got enough information in there where we're starting to look at where our pivots are. You can see there's a jog on the upper portion back there after the B pillar. That jog is specific to where the pivots are for the lower link and the upper link. And then it's starting to come in as well. And then we're going to kick right after the cab, and we're going to get all the setup for the up travel that we need. 12 to 13 inches at ride height. We're also able to lay this frame up into the cab like a body drop, super clean. And the most important thing too, for at least the section under the cab, is that we get to spread it out wider, so then we can land all the tubes in a much more orthodox fashion into the frame. You know, all the roll cage, the A pillar, the B pillar, the C pillar, all that doesn't have to do some weird thing to bring itself back into the frame, you know, and we get a much more structurally rigid situation here. So, you know, this is the beams, we'll cover that, but really that frame rail section is going to be the first thing we're going to build out, and that's what we're in process. The shocks are done. We're running a 3.5 inch king coilover front and rear. Your usual, like your typical trophy truck, is a 3 inch. Since we're just running one shock on each corner, it's a 3.5 inch coilover. So the spring is going to be massive, and then a 2.5 inch bump. They're custom colors. We're running International race cars front and rear hubs. Those are the same thing that you'd see on the Willys. Then we're running their heat treated MIG welding housing in the rear. You know, jumbo axles, all the big stuff. The win you get with running big parts on something that might not be an extreme duty and extreme use vehicle is that your intermittency of service, like your intervals, is drastically less. You know, you get something bigger, so you don't have to service it as much, and you can count on it. You know, it's something really important for me is hubs, getting the corners to be the strongest, because one of the biggest, gnarliest things, you know, under a full-on crash is a wheel popping off at speed. Which usually will end up, best case, you won't flip. Worst case is you're gonna hurt yourself. So those pinnings on the corners are the most important thing. Having a strong rear housing, having a good gear, having a good transmission, powertrain, all that stuff is stuff where we can build a very simple car around all that, and then we just know we have these proven, dedicated, severe duty parts on this farm truck. So that's what we're getting right now. I think next week we're going to pick up the housing. Shocks are ready, the hubs are ready, and then we can talk about what we have right here. Before we get into the suspension, so like what you guys see right now is, this is what we need. Like, this is our table that we're using. This is actually Carl Renesender's table. Thank you, Carl. He let that one go and we inherited it, and I love having stuff with heritage. We have a Dave Clarke table now, and now we have a Carl Renesender table. One of the things we need to do here is, this is our planning table. So I think we're gonna build all the frame rail out on this table, so when we weld it and we put a bunch of heat into it, it doesn't tweak. But right now what we wanna do, maybe Joe, if you come from over here, you can see it. We have an open canvas to get the wheelbase and the tire centers and the wheel openings exactly how we want. This thing's still gonna be pretty long. It's 140 inches. That's with like a 5-inch shortened bedside on here, running the bedside right to where the door seam is. And then what we're doing here too is we're gonna pull this tire forward a little bit, and I kind of have just a mock-up cut in here. But what this lets us do is this pulls, Luke is working on the computer, and then he can come over here, I can get with him, and we're pulling dimensions. Where the A pillar tube's gonna wanna land, the B pillar is gonna wanna be 60-inch link, where The link pivot's gonna wanna be in relation to the kick in the frame, in relation to where the B-pillar is gonna land. So we're gonna get all these wins by just logging data. So this is really just our, our measurement table of where we can plot all that stuff. And that's what he's doing. He's pulling stuff to where the axle is gonna be and the center line. And then we're able to just literally have a live example of something of how we want it. So really what we're doing right now is we're working from a pillar rearward, closing that out right to where we're putting a fuel cell in, keeping that simple. We're not building a can, we're not building a tank. We are just gonna order a 70-gallon enduro cell. That's gonna live back there. We're gonna build everything to that spec. And then we're gonna come back here and figure out what we can get for up travel, where the kicks need to be, how that's gonna favor the headers, knowing that the headers are gonna go inside the frame rail and then they're gonna run along the whole side of the frame rail. Thinking about all that stuff, thinking about the swingers, the pivots, and clearances. We have like this very fresh opportunity to get this frame streamlined where we're not gonna have interruptions based on the factory dimensions of this thing. We've been doing, so this will be in April will be our 6th year in business. We have done everything with a bandsaw, some plasma, and then any parts like really vital assemblies we get laser cut. But we got a plasma table. It's a big 4x8. It lives in the other shop we have here. And that thing has started to really, I feel like this is 30-year-old technology. But my concern was always, how do you take these organic templates that we're doing that aren't just geometric shapes and parallels and radiuses and transition those into a table that can cut them without taking the time to absolutely redraw all these fluid shapes in SolidWorks and then cut it. And what we have is we have a trace tool that logs all the data live. It calibrates and it logs it. And Fitch, thank you so much for helping with this thing and getting me on board. And now my guys they all know, they're all fluent, so they go over there, they do their template, boom, this thing calibrates it, logs the data, cuts it, and we're not drawing it. But the other window we have is now we're able to cut all of our parts in-house. So all these beams, this is all Jason Hurd stuff. So this is gonna be one of the beams. It's got a huge bearing on the outside, so this will have adjustable camber. And all of this is from DIY. The best thing is obviously Jason, I have a relationship with Jason. I don't want to use all his parts, we'll use his hubs and everything. But the best thing is we just cut this stuff in-house and then the guys prep it and they assemble it and we're just streamlining. We're not doing any middleman stuff. We're not waiting on anybody else. We can just do it live. So this is going to be the first kit that we cut here in-house and then we assemble and use on our car. Things to expect with this. I don't know if we have a ton of update, but maybe I kind of run through some of the cabin with you and some of the details I'm expecting. But at least next time you check in, we'll definitely have welded beams. This is part of the radius arms. Welded radius arms, all ready to go, all prepped. Probably have the front section of the frame done. The beams hanging, we're gonna do all the steering too, but we'll at least have the beams, the radius arms hanging on the frame. I am not gonna be doing center mount radius arms. I think that's a glorious thing for geometry and possibly even strength, but for serviceability. You cannot get your trans out if you have center mount radius arms unless you remove your suspension. You remove your radius arms. If you can do it in a way where something doesn't twist and go crazy on the beam and you can just remove the radius arms, cool, but more than likely you're gonna have to remove your shocks and then you're gonna have to remove your radius arms. So for serviceability and simplicity, I just want a nice clean radius arm that's gonna go right to the frame. The other thing we wanna get after is not having any pivots hanging down substantially. There might have to be a little bit to clear the bolt, but nothing where the pivots are like these big appendages hanging off the frame. So I think we're gonna get a lot of wins using the A500 tube and, you know, set this thing up proper. So note the seam location being the most hidden location on the top. Then everywhere that we have a splice, which would be a splice here, is beveled. So we'll full pin weld this. We'll do a secondary weld on top of it. And then if it's not occupied with a bracket, then we'll have a nice overlay. Like some of this stuff where it kicks after the frame. You know, the goal is anytime you have a directional change on any part of the chassis, you want to have some kind of a support center for the directional change. So like in this jog here, imagine that the upper link bracket that's going to be on the inside of the frame is going to tie into this, and then the lower link bracket is going to tie into this, and that's all going to add this extreme element of strength right here. Where this kicks up right at the edge of the frame is probably where we're going to have some tube tying into stuff as well. So when, you know, I think when we check back in with this, and hopefully I can vlog some of this where you're just going to see it in motion and see it happening. But I think once you check back in, this whole frame will be under the car and the suspension will be hanging in the front, possibly in the rear too. It's going to be a lot easier because we're just running an axle, you know, with one link non-trailing arm. You know, the coilover is going to be off the axle. On that note, the rear coilovers are also a 20-inch stroke. So we're doubling down on as much travel as we can get on this thing. This should be a big, squishy, fast truck. I know Robert with Maruzzi Race Engines I know we're close to him starting on our engine. So I want to say it's either a 545 or a 575 cubic inch Ford, all fully built, expecting big numbers, pump gas, and then a 8 HP gearbox. So that's out of that's a Chrysler gearbox out of a Hellcat or a Demon. It's an 8-speed. Put it in drive, let it shift. It has a electronic clutch, an E-clutch they call it. And what that does is every time you hit that button, it clutches the car. So like say, it's a very different driving method, and we're not gonna do paddle shifters. I want this to be a family truck. I want Eric's wife to be able to get in here with her kids and enjoy this thing and it not feel like a machine. That's the whole thing. It's just 2 rows of 3-seat benches. She gets in, she puts it in drive, and it shifts. But if you want to have fun with it, it will have a full manual mode, and then it also will have an E-clutch. I almost said E-brake. It'll have an E-clutch, and what that does is, like, if you had that on your steering wheel or something, when you're going around something and you want to clutch it just like you dump with your foot, you just tap that thing and it engages the clutch and it does the same exact thing. And it'll let that thing kick out. So I think that should add for a really awesome driving dynamic. So all these are all knuckle parts. Root pass, and Colin is preparing all this stuff for fabrication. This will have a big gnarly fabricated knuckle. I don't know what brakes we're gonna use. Something, if you guys are trying to be on somewhat of a budget and you want big brakes, one of the biggest ones you can do is use factory OEM Brembo equipped car brakes. Like for instance, I have a Cadillac CTS-V. If you looked up Cadillac CTS-V brakes on eBay, or maybe even on Marketplace, you could find a quality 6-piston big brake package from Brembo at an insanely cheaper rate than you would buy a Brembo brake package. And you're gonna have just as much success using those things. These are Fittipaldi wheels. Duke, our wagon, Dolly, and a couple other trucks. Kevin's Raptor. All of them are running these Fittipaldis. I'm super pleased with these things, and I'm grateful to have a relationship with them. So this is going to be our Dolly wheel and tire combo. Your typical. This is their newest race compound BFG from Jackson. And then that's our 6-on-6.5 trophy truck hub beadlock. Gonna leave it like that. Machine finish, powder coated lip or powder coated ring. And that's really, I think that's the win. That's the same as our wagon. There's something really good about that gloss black I'm all about kind of contrast and different finishes. So like having a gloss next to a flat is what I see here. And it also makes the wheel look a little smaller, and I always like a smaller wheel in the tire than like a bigger wheel with less wall. One thing we're not going to do is fix the bodywork. Not to say we're not going to have it fixed, but there's some spooky stuff up here. Same when we cut the light bar tab off. There's things that I know better than to get into and try to get a win with when there's other people that can do it. So once we get this thing all dialed, we'll bring it to the body shop, we'll get it gapped properly. We'll get the drip rail delete done properly and some areas filled and smoothed out. Something to look at in here, we cut part of that firewall out, but what we also have is we have the factory dashes retained. One of the important things here is to use the factory dash and the sheet metal. Like, it's a beautiful sheet metal shape. A lot of these cars came with really cool steel instrument panels, and we're gonna keep that. We wanna keep the flow. I don't wanna add anything in here that looks modern or takes away from the heritage of the 77 F100. The firewall we can look at from the front. This is something where it's the same battle as the frame. When there's so many holes, you see a clean return edge here where you know what you can do to make this right. You know you're gonna fill a plethora of holes in here, and it's gonna get distorted, and it's just, you gotta weigh that stuff out. You know, time. What is the time gonna be versus cutting a portion out and putting it back in a clean way where it just has like your areas of service, your steering shaft, your brakes, and that's probably it, and maybe the AC bulkhead on one side. And then we literally do nice bead rolls that favor all that, and it keeps that clean hot rod look. So that's what we cut out of it. I don't know if we're gonna have to cut any more for the tires to clear, but since the front tire has moved forward a little bit, we might be totally good. Again, the intent for this thing to bottom out is gonna be with the top of the tire being under, you know, the highest portion of the fender. Same with the bedside, same with engineering the frame. Bedside goes on there. We measure right to where the top of the tire is gonna be, almost contact on the bedside, and that's where we make bump. So that lets us also have a ride height where this thing sits super low, it's super wide, but it's actually functional. Sometimes you'll get lost in that where you think it looks sick and it sits low, but then you go to hit something and you go through a really cool buck before all your suspension starts to work, and that upsets the car and that makes it more dangerous to drive. So we should have quite a bit of stuff here going. This is one of these consistent projects. So, you know, Luke's taking this on. I'm so proud of him for doing this. And it's great because he has a skill set in SolidWorks. So we're able to exploit that and see the gains. You know, I like to see someone, I know what Luke's going through. I know that he's waking up focused on a task now, and he's thinking about that. And that's my favorite time to be on a job, is when I'm sometimes going to bed, or I'm waking up first thing in the morning and I'm leaving off thinking about how I'm going to attack the next phase of whatever I'm doing. And that's always the best. You know, sometimes we're working in here where we have to make it work as a team. So sometimes you're on one thing and then you got to go do another thing. And I think right now it's exciting because he's really driven on to getting this thing into a spot where we get a big win. So that's the Dolly update. We'll check in later. I hope you guys have a good week.